Okay, hello everyone. Uh, Good afternoon again. Let me just introduce myself. My name is Sandy Baresi Shagota, and today we will continue with the practical data collection class, starting with the data redundancy topic. So, just to reiterate, the last time we covered two elements, two topics. First was the importance of expert knowledge, where I tried to illustrate why is it important to have experts near you when you are doing data collection and when you are designing data collection processes. And we covered some data tracking, so how can you use statistics and some basic distributions and descriptive statistics in context of tracking data and making sure that your data is fine as you are collecting it, whether you are processing it real time or as you collect it. Okay, so today we're going to cover the topic of data redundancy in practical data collection, and we're also going to talk about ethics and regulations in data collection. Those are our goals for today. So let's start. So whenever we are collecting data, the key part of collecting data is actually storing it somewhere. And where are we storing it, how we are storing it, is critical to ensure that the integrity of the data and that the data is safe, that there isn't any loss of data that we can't recover from, and so on. We also want to choose storage that can be accessed for long term, and so in the future, if we want to check the data or check the raw data that was collected, we can easily access that. We don't want to select some storage media that might be hard to access. One of the examples today is our DVDs, and not everyone will have a DVD reader or something like that accessible. So if you're storing data on that sort of media, it may be a problem, in the future to access that. So we don't want to use something that's already old, that's already out of date, and potentially, will cause this problem in the future if we want to re-access that data. And obviously, we want to be able to reproduce experiments. We want to be able to reproduce any experiments or anything happening with this with whatever is going on, whatever happened when we were originally collecting data. We want to have that exact data stored so we could reproduce those results and see what's happening, what was happening, and what was and potentially determine any information that was inaccessible to us. So, what are the basic principles we want to check here? First is that whatever storage medium we select has enough storage, has enough capacity and reliability on its own. So we don't want to select anything that is a potential issue that is a potentially can cause us that can potentially cause us issues. So an example is a hard drive. If we are selecting a hard drive, right? We don't want to select a hard drive in an area where we're going to have a lot of vibrations, a lot of problems with data storage that can, if we have a heavily magnetic area, for example, in CERN, right, where we have a particle accelerator, for example, or any other magnetic particle accelerator, you don't want to use something that is magnetic. You don't want to use tapes directly there for direct data storage. You don't want to use hard drives for direct data storage in such environments. So the other problem is, of course, capacity. You need to be able to determine how big of a capacity your data will approximately have. You need to have some know-how, some basic information that tells you whether, are you going to be collecting terabytes of data today? Are you going to be collecting gigabytes of data? Are you going to be collecting much more, much less data? That you need to have there. The second is, the storage, whatever the process you're storing it on the storage, you want to make sure that data formatting is as consistent as possible. In big data class, if some of you are participating, we talked about inconsistent data and inconsistent data storage. We had varied data and stuff like that, and how that introduces complexity. We generally want to avoid that. So if you can avoid it, that's something that you want to do. You want to avoid having an issue where your data isn't structured properly, because you will need to invest more time in processing it later on to get some proper insights or something. And a lot of people don't want to invest this time when the time comes for you to do it. It's much easier for you to give them data that can be used directly. Think of it, if you are selecting like from Kaggle or somewhere, you are selecting a data set. Are you going to pick a data set that you need to do a lot of processing on, or are you going to pick that same data set with the same topic that was already pre-processed, and you have a nice CSV file that you can just plug into your Python code and encode and run analysis on, develop a machine learning model. So that's something that you want to have. You want to verify any data that you're storing, whether it's whether as you're storing it, whether at varied time intervals, at whenever you're finish an experiment, you want to verify the data that was collected previously, that kind of time. But you want to do some sort of verification on the data occasionally. And another thing is you want version control. So there are a lot of version control software out there, such as Git or SVN, that will allow you to track any changes that are happening. So you can go back. So if you're inputting new measurements and stuff, and you realize you screw something up, you input measurements that you shouldn't have, that sort of software, using that sort of software will allow you to essentially roll back to the previous version of the data that you had, eliminating, if there's like a large scale corruption of your data, you can roll it back, and you can detect corruption because you can detect changes between different versions. So that's something that's very, very useful to have and to implement. We talked about this in data storage management, redundancy. You want to have redundancy in whatever you're doing, whatever storage types you have. It doesn't matter. You don't want to rely on hard drive being perfect, or whatever you're using, SSD, flash drives, SD cards. You don't want to assume they're perfect. You don't want to assume that they are going to work perfectly. They can break, and the only way to really make sure that this is not a problem is if you have redundant storage. So a lot of, for example, scientific cameras will offer you to redundantly write to 2 SD cards in case one of them fails, right? So you don't lose data and that sort of things. As it says here, you don't want having multiple copies on an SD card in your drawer doesn't mean anything. You want to have it stored on different devices on different locations. You want to use system that exists, if you can. Why do you want to focus on RAID, cloud-based backups? Because those are systems that people use. They have been tried, tested. We know that RAID works. If you develop like some sort of your own system or something where you're trying to organize it or whatever, it's not really. It can cause a lot of problems. And again, redundancy isn't easy. If you're collecting a lot of data, copying that data, uploading it somewhere, it takes time. So you want to prioritize it. You want to make sure that it's done for, first for the critical data sets or data sets that can be easily replaced, that you can't just, recollect again or something like that. So when we're talking about storage systems for doing measurements or any data collection, when I say measurements, I don't mean necessarily actual, voltage measurements, something like that. Measurement can represent a video, measurement can represent a photo or anything like that. I'm using measurement in a scientific sense. So where are you going to store it? You can store it locally, on your SSD or HDD, usually immediately as you record it from whatever device you're using to record stuff. You're recording it to your computer, storing it on your hard disk drive. That's an example. There is also network storage, so you can automatically store data over the network to network attached storage or storage attached network. There are different approaches. We talked about this in data storage management, Samba and so on. This is great if multiple people are accessing stuff, or if you are collecting stuff for multiple sources, like you have multiple cameras connected to multiple computers, because you can connect to a single computer for some reason. Writing to network storage is an option in that case. Cloud storage is a step above, when you are, instead of storing it on your local network, that's when we say network storage, that's what we mean. You're using, remote storage that's usually scalable, that you can increase it easily. That's the main benefit of it, and it usually automatically offers redundancy built in a way you don't even see it. You don't even have to worry. It's not your hard drive; it's Google's hard drive or someone else's. And when it dies, they're taking care of redundancy at that scale. You don't have to worry about it. That's the benefit of cloud storage. There's obviously a problem. There's a bigger link between your device and your local storage. It's a USB cable. Your local network storage, well, it's at very least like a network switch. And if you Ethernet cables, cloud storage, well, you need to go to the outside network. And the more complexity you introduce to the actual connection, the higher the likelihood of an error happening. If you're writing something to cloud storage continuously, there's a high probability of an error. So usually what happens, if we want to make sure, you will combine both. You will use local storage to make sure everything is saved, and then you are at the same time uploading the measurements you do occasionally to the cloud to make sure that they are stored properly, and that if something goes wrong, if your local storage, you don't lose anything, because or you lose at least a smaller amount of data. So when we're talking about real-time data storage during measurements, we usually talk about data acquisition systems, DAQs. These are the systems that are designed to do live recordings. You can think of this as video streaming. If you are recording a video of something, that's essentially live recording. What do you want to do here? Well, real-time data storage falls into a couple of problems. One is interruptibility. If I have a measuring device somewhere connected to, for example, my electrical network, it's measuring stuff. Great, not a problem. But considering we're doing, a proper measurement continuously here, what happens if our device, our computer, we are recording it? What if the network, the electrical network gives out? We lose electricity. We want to make sure that we have enough power all the time, so we have battery power supplies, uninterruptible power supplies, UPSs, making sure that there is no sudden data loss because of our network going down, us getting like a short brownout or something, and our equipment shutting down. That's something that we want if we are continuously collecting data in an automated manner. Another problem is we want some sort of automated monitoring, not just of our electrical network, but of our storage and of our network as well, if we are using network attached storage or cloud, because we want that information to be shared to us as soon as possible. So we might have something like an automated text message or email, or even an automated call to our phone, to an administrator phone, if something that's mission critical, data collection goes out, the electricity goes out, or the network dies, or the hard drive is getting full, something like that. We want to have some sort of a monitoring system that's going to notify someone. How is it going to notify them? Well, that depends on how important the system is. For some stuff, it might not be necessary to call someone at 3 a.m. in the morning. For some stuff, you might even have a personal call someone right there in the laboratory 24/7 to monitor it, right? So it really depends on what you're collecting and how sensitive it is, and how valuable it is. Okay. And another example is, if you're doing data uploads or something like that, have something that can act as a buffer, right? That will, like a storage device that will store part of the data. So it might do something like store maybe, last hour of measurement, last couple of days of measurement. It depends. Usually we're talking about a separate device here. So you have your measuring device, you have your computer that's going to store the data, upload it, whatever. And then in the middle, you're going to have another device, possibly battery powered, or something like it doesn't have to be anything crazy, just like a small, Arduino or Raspberry Pi microcontroller, microcomputer that's just going to store the data, write it locally to an SD card, and then send it on. That's something that can be used as a buffer. Of course, be careful if you're doing something like that. If you're doing digital data, there's less risk of noise, but if you're doing analog data, that can definitely introduce noise into your system. So that's something to be careful about. How often are you going to back up something? That's something that gets asked, a lot. And to me, it depends, right? As a lot of things, it depends. You have a data that changes a lot. You have a data that's extremely varied, where the variance of the data is high, and you want to store even the small changes in data, not small in terms of, but time-wise, like high frequency changes in data. Well, you want to do high frequency backups every minute, every hour. It doesn't matter, but something like, a stock market or something you want to save very often. Some stuff, what's the point of picking it up more often than once a day if it's not changing more than once a day, right? So that's something that you want to have, daily backups and weekly or more often or less frequent backups for dataset that are rarely updated or essentially static. What do I mean by static? Why are you updating static datasets? Well, because backup, and this means, if we have a dataset that's static, that isn't getting updated anymore, and you try to upload it somewhere, you try to back it up, you can check immediately if it's valid or not, if there was a change. And if there was a change, the copy that's on the cloud somewhere and the copy that you have on your computer is the same, there was some corruption, something happened, a value changed somewhere, and you need to, address that and raise an alarm of some sorts, check what went wrong, where was the problem, where did the problem happen. And as I said again, the frequency of backups will depend on how often data is measured, right? Again, the more often the data is measured, the more often you want to upload it, because you're losing more data points, right? If something is updated 100 times every second, that means that 100 times every second, we have 6,000 measurements in a minute. So if you don't update it, or if you didn't pick it up for a minute, you're going to lose 6,000 measurements. If something is updated every hour, you do measurement every hour, and you didn't back up the data from that, in a day you're going to lose 20 data points, 24 data points. So that's not obviously you need to store it. Never have a backup more often than the frequency. That doesn't make sense. You're just wasting energy unless we're talking about a static data set that isn't updated. Do occasionally update them to make sure everything is fine and there are no unexpected changes. So what are some practices for actual redundant storage? It's use 3 copies of the data. Have the original, local, and remote backup. Why? Because if your lab catches on fire and your backup and your original gets damaged, you have a remote backup somewhere else. You want to use RAID or similar techniques, but RFS, unRAID, whatever configurations for tolerance, for fault tolerance, during measurements as well as for storage. Test backups, test recovery processes, see what happens, simulate errors occasionally, because if your backup doesn't work, you don't want to figure that out when you need it. You want to figure that out while you still have the original data. So occasionally, have a plan for testing that your backups actually work. That's something that a lot of people don't do. And I've seen a lot of people get burned by that, where they will do something like, oh, this ancient external hard drive is my backup of everything. And then their computer dies. They dig out that hard drive they haven't turned on in 3 years, plug it into their computer, and the hard drive starts clicking and it doesn't load. So don't do that. Check your backups relatively often. Make sure they are working, make sure everything is there, and make sure you can restore data. And as it says here, as I said, don't store everything on an ancient hard drive. Stuff happens, rotate it. If the storage media has a big problem when it comes to failure, it doesn't let you know it's going to fail. It just fails, right? It's not something like a car where it might be working a bit slower. So I haven't changed the oil in a while. Let me do that. With a hard drive, it's going to fail immediately. It's going to just it works now. You plug it in the next time, it doesn't work without any signs of problems, at least visible to you as an end user, right? So don't wait for the media to die. Don't be like, oh, it was fine last time I plugged it in. If you have important data stored on a hard drive somewhere, and it's been like 4 or 5 years for that hard drive, don't be crazy about it, especially if it's your personal data, if it's not something crazy. But if it's been a couple of years, and you find a good sale on an external hard drive, buy it, use that for backup, and use this drive for something else. That's my general advice. When it comes to laboratories and teams collecting data, I usually tend to tell people, hey, if you are if it's been like once we in science, we usually get some funding once a year. If you get funding, when you get funding, one of the points should be updating your backup storage media and your storage media in general if you're doing a lot of measurements, because hard drives fail, right? Yeah. Then this is something that you will hear a lot. 3-2-1 rule. You want to have at least 3 copies of data on at least 2 different mediums, and at least one of them being offsite. Why 3 copies of data? Because, well, stuff happens. As I said, backups fail, and if your backup fails, you may prefer to have another backup. So make sure that if you have important data, you copy it 3 times. You have an important data set, copy it immediately, in 3 places. Try to use 2 different mediums. So try to use, if you're using hard drive, also store it on an external SSD. If you're using an SSD, upload it somewhere, to make sure that it's two different elements. Why this is mostly for posterity or for unexpected circumstances, where you don't want to know if someone accidentally, throws a magnet near your hard drive and damages it, or you accidentally drop your hard drive. If you're keeping, if your two copies of data are on hard drives, and you don't know that your assistant was cleaning the laboratory, it dropped, they dropped the hard drives on the ground and pick them up, put them back on the table, and you go to check them out. Or you suddenly have a problem. The data is corrupted, and you only check them because the data was already corrupted on the main computer. You have lost all the data. It's a problem. So keep it on keep it on USB. USB won't get damaged if it drops, or upload it to the cloud or something like that. And again, as I said, it's also for posterity. If you store stuff on a CD, right, as a backup right now, and 5 years down the line, if, for example, you stored it back when I was a student, DVDs were popular. I'm not that old. DVDs, storing data on DVDs. I have a lot of data that's stored on DVDs because that was the simplest way to transfer larger amounts of data. And it's practically worthless to me now because I don't have a DVD reader in my computer, right? So if I needed to get something like that, I would need to buy a DVD reader or get it, and that can be a problem if you're doing something that's mission critical, that you want to access the data quickly. And again, as I said, you want at least one offsite in case of errors, in case of really catastrophic events. Where you can get access to the actual building where you're storing information. In addition to that, you want to validate and verify data. You want to validate any data that's created. You want to make sure that it's well stored, that it's right there, that you have enough information where that data is valid. If some, how can you do that? As I said, there are systems that use checksums that allow you to do this, or hash values or stuff like that. We talked about that in data storage and management, but you can, have a checksum and have preferably an automated system that will go through all the files that you have stored somewhere in a backup and check the checksums, make sure they are fine, and notify you if they aren't. So make sure that it's automated, because if it's not automated to be run automatically once a week, you simply won't do it. You will forget. If it's really critical, use ECC or advanced file systems, error correcting stuff to make sure there are no errors if it's really, really critical, because that's usually expensive or it penalizes your performance. And finally, you have, if you're storing document storage, if you have verification processes, store them for accountability, so you can verify that how this was done. So if someone asks you, is this data valid? Are you sure you have a documentation that points to, like, it can be as simple as every time you have this automatic run, write a log file that says on 13th December 2024, data was checked, 0 errors found, and do that every time. And have a log that checks. So if someone asks you, like, hey, are you sure this data is fine? You can show it, yes, this is the methodology that we run. We use this checksumming algorithm to generate the checksum. We compare it, and here is the log that shows, here's the code. Have that written down, verified, so people know that your data is fine or not. What are some elements, another that you want to consider when we're talking about long-term storage? We're talking about storing data, not just until tomorrow, until next week. We're talking about storing it long term. First is formats. If you're storing it, I don't know if I talked about it in this class or something, but a colleague, an old friend of mine, an old colleague of mine contacted me recently telling me like, hey, we have this thermal camera and we have some measurements on it that we need to get off with, but we don't have the software anymore. The software doesn't exist. It has been discontinued. We tried to contact the manufacturer, and they basically told us we don't support that anymore. Buy a new camera, right? And they said it's not a problem to buy the new camera, but we want, to get the data that's on this camera off of it. What are we going to do? And that's the problem, right? Because the storage system that they had, the format that they had on there was some proprietary software that we needed to essentially backwards engineer and figure out what's going on, what it says. So if you're storing data, don't be creative. Don't use some special formats that you are, you want to design if you don't have to, if you aren't directed. If you are directed by a manufacturer to use like a specific format, see if you can convert it into a format that's more easily accessible for storage, like CSV, comma separated values, where you just have, which is essentially a table, right? You have rows of values where columns are separated by commas, right? Same goes, HDF5 is a simple storage format, etc., that you can use to store information, and that's well documented, widely used, and you don't have to go on hunt on reverse engineering spree to try to and figure out how the data has been stored and to reaccess it. Again, technology evolves. Old technology not only gets less usable and harder to access, but it actually has a higher probability of errors. Don't be afraid of new stuff. Migrate once stuff is confirmed to work well. Don't be people who were at the cutting edge get cut by it. So don't be on the cutting edge, but once something has been confirmed, if a new technology exists, try to use it if it's valid for your use case, of course. Review data, review your storage policies. So not just the data itself, but the policies to make sure that stuff is done properly. Why? Because stuff could have been updated. RAID was 15, 20 years ago. It was the gold standard, and it's still used, but there are now better systems than RAID for certain use cases, right? So make sure that maybe you will want to update to a better, different system. And you want to make sure that any metadata any data that stores has appropriate metadata. This can be as simple as having a description on what the data is, when it was collected, and so on. Because in the future, if you have something, 5 years from now, you open a directory and it says something like robot.csv, and there are a bunch of numbers in there, and you don't know what it was generated for, why it was generated, what's going on. Keeping an extra text file next to it, or having a header in the file or something like that just says this file is so was collected on that date and this date. It used the methodology that described this article somewhere, and it collects information on this, and this. Right? That's enough. It doesn't have that metadata doesn't have to be anything wide-reaching or scary or but have some information that points you to a certain direction, and that makes you want to actually reach that and understand what's going on with the data, because believe me, the amount of storage that may have been lost because you don't understand what it is, that's essentially something that you want to have metadata accompanying all of the information that you do, and just practice yourself, learn to do it, learn that when you're writing Python codes for storing data, make sure that you also write some metadata to a file next to it. Just learn to do it automatically as a good practice. Okay, so we're going to now talk about our next topic. is ethics and regulations. Basically, whenever we're collecting data, today more and more, whenever we're involving people, animals, in living beings, anything that is close to the people, there are ethics and regulations that exist that we want to discuss, we want to follow, we want to understand, and so on. So let's talk about this in this topic about what are the ethics of data collecting, what do we need to pay attention to. Again, if we are talking about collecting data from a robot or a sensor somewhere, it's not necessarily problematic, but more interesting data today is sourced from humans, is generated by humans in some way, and we want to make sure that whatever we're collecting, that the data collection process respects the individual rights and their privacy, so it doesn't collect information beyond what they want to give us. We want to put an emphasis on fairness, right? So the people understand transparency, so people understand what's going to happen, what the data is going to be, the data is going to be used for, and who is accountable for that data, which people are in charge of it, in charge of what the data is, where the data is stored, where the data is used. So, and that is critical because without that, today people are growing more and more privacy data conscious because they understand that there are risks with sharing their data with anyone. Back in the day, no one cared. You could, I remember even some doctors getting like annoyed because we'll be like, "Oh, did you make sure to check when you collect the data?" Is like everyone says, yes, no one cares. But today that's not how it is, right? Today, when you ask a patient, like, "Are you fine?" If your data being used in a study, if you ask them if you aren't doing something inappropriate, because sadly that's something that happens a lot. If you're doing it properly, asking them, you will get questions. You will get to what kind of study, for how long, where is that data going to be kept, can I revoke my consent if I change my mind, and stuff like that. So that's something that you want to have that transparency, you want to have that accountability to make sure that people can form that trust towards you. So, what are the key ethical principles that we want to cover when we are collecting data? What are the key elements that we are giving here? First is informed consent. We want to make sure that people understand that people agree to give us data collection, the data for us to collect. And when we say informed, obviously they need to know about what's going on. It's not just like, hey, can I collect your data? Yes, we want to tell them it's going to be used in a study, because some people might assume that they are fine with it, and then later on they figure out they aren't. They maybe hate AI and they don't want their data to be used in AI research or something like that. So yeah, that's essentially a possibility. Then we have data needs to be anonymous and confidential. Anonymity means that the data isn't doesn't have a name, doesn't have an identifying number, address, something like that, personal identification number, your ID number, anything like that. We don't want any unique identifier that could be tied back to a person. And if we want to keep it confidential, whether it's anonymized or not, we want to keep that data away from public eyes unless explicitly we were given consent to publish it online, like in a public repository or something like that. Then we have data minimization. What is data minimization? It's just if we are collecting certain amount of data, we don't want to collect everything about that person. So this is something, again, we need experts here to help us figure out what is the actual data. We don't want to figure out a year down the line that we need additional data points that we didn't cover. And finally, we want transparency in studies, in how it is done. We want to tell the participants in the study exactly what we're going to do, what's going to be used for, where do we plan on publishing the data, where do we plan on publishing the results, what the results may be used for, and so on, so they can make a clear, informed decision about where the data is being used. So how do we make sure this actually happens? Well, we bring regulations at the government level that are essentially laws that tell us how is it fine for us to collect data or not. And we want to again protect individuals from misuse of their data, from personal attacks, from revealing elements about them that they don't necessarily want publicly known, for example, their medical history, etc. Another thing is that we want to have consistent data handling across different approaches. We don't want to have our hands tied in medicine, right? And then have someone who's doing social sciences be able to collect whatever they want, or vice versa, right? We want to essentially have a consistent rules for everyone that are dealing with data. Does data need to be anonymized? Yes, every data needs to be anonymized, and so on. Same goes for different countries. We don't want to, what happens when, you are, if I'm in Croatia and I don't have any rules here, for example, we do have rules, but for example, just, saying that we don't, and I send you anonymized, data with personal identifiers to you, and you are in Greece where you have rules, you're breaking rules, right? Your own rules, because so we want to make sure that at a larger level, these at least basic regulations are followed. And essentially, how are you going to get that? Well, you can set penalties. You can refuse studies that don't follow certain regulations. So refuse studies that don't follow certain regulations, or just monetarily fine companies that don't do it properly, and so on. European Union is, for example, pretty proactive in this area. One of the examples is GDPR. If you're an EU citizen, you have probably heard and very possibly encountered certainly with GDPR, which is the General Data Protection Regulation, which applies to everyone, everything, everywhere. So it applies in European Union. If you are a member state of European Union, your government needs to follow this. Any companies within it need to follow it, even if they're working with foreign citizens. And what does GDPR mean? Essentially, it provides the right to access. So if I believe that you have my data, I can request it, and you need to show me what data you have on me, right? That's great, and you can do it. Right now, you can see, if you're curious about what data Facebook has on you, you can actually put in a GDPR request and see. Same goes for Twitter or any website like that. They will show you what data they have, and I encourage you to do it, because you may be shocked to see the amount of data that they actually stored about you. In addition to access, you have the right to request that data to be erased. It doesn't matter what kind of company. It doesn't matter that it's Microsoft or Facebook. Actually, Meta is the name, right, of the company. You have the right to request them to delete that data. They have to comply, or they will be fined. If there's any data breach, any data leak, right? For example, Sony had a famous data leak where they leaked a lot of credit card information. Those leaks happen, passwords leak, stuff like that. If that happens, under GDPR, the company needs to notify you within 72 hours. No matter whether they fix the data breach or not, in the meantime, they need to notify you within 72 hours. or otherwise they will get fined. Why not shorter time? Because companies may not notice. It's sort of a happy medium, because if you say something like, 24 hours from when you notice, companies will just say, oh, we haven't noticed at all, ever. So they give them 72 hours to basically be from the point that they have informed that the data breach happened, data was shared somewhere inappropriately. From that point, the company has 72 hours because that's the amount of time where they will very probably figure out that something went wrong. And finally, the companies above a certain size need to have a data protection officer. Not just companies, but organizations in general need to have a data protection officer that is going to make sure GDPR rules are followed and regulated. These are the people, depending on the size of the company, that will provide you your data when you request access, and so on. Obviously, some companies will have automated systems for this. Another example is HIPAA. HIPAA is Health Insurance Portability and Accountability Act. That's focused in United States. Again, when something is good, we have a tendency to try and follow it, especially for global collaborations, because if I'm working with a hospital in United States, I need to follow HIPAA, with the data that I am following, and basically it governs any healthcare data in US. Patient information is protected by controlling who has access to it and how and to whom it can be shared. So not only who can access it, but I can just, if I have the right to access that data, I can show it to anyone. I can only show it to a person who will be able to access it, right? The identification, so that anonymization that I mentioned, for any secondary use. Secondary use is anything that's not directly relating to you, so any studies, anything like that. That's something that HIPAA regulated that we are also using. And it also has rules for storage, transfer, and sharing of electronic health records. So any information about the patient, how it needs to be stored, how it can be transferred, and how it can be shared is regulated all completely by HIPAA. That's something that an example of usage. Why is informed consent even important? Why are we using it? Why do we, even bother with it? And how to, provide people with informed consent. I mentioned again, not everyone is fine with their data being used everywhere. Maybe they are fine with something like, me using it because they go, okay, he is maybe an older guy, more professional, great, but they don't want students to use information because they may be like, oh, students are a bit less professional. Is that true? Not necessarily, but that's their freedom, to select whether they can use their data or not there. So you will inform them. As I said, some people are extremely anti-AI, so they don't want the data to be used in AI generation. That's, again, they're right, especially under GDPR. So what does informed consent include? Or if you want to check that box that your patients have provided, that your subjects have provided the informed consent, you need to have stated the purpose of data collection, what is the study, the type of study, what's going to be used, etc. What is the duration of the storage? How long are you keeping the data? We're keeping it for 2 years to do this study. We're keeping it for 5 years because it's a more complex study. We need more data. We will keep it indefinitely. That's also an option, right? And you need to share potential risks and benefits. So we can say like, hey, benefits are more not a must, but it's provided. In this area, it means not benefits in the sense of, hey, how it can benefit a person, how it can benefit. You don't have to tell them like, oh, this is going to benefit us because we're going to develop a system that's going to allow us to classify between. No, it's if this is paid, you need to tell them it's paid. You can try to skirt that around and be like, oh, this is a paid study, but like if I don't mention it and he signs the agreement, Yeah, or if there's, for example, they might get prioritized care because of it, you need to tell them like, hey, you're getting prioritized care because we prioritize patients that are included in the study, so on. That's something you need to inform in addition to risks. Standard the risks are, hey, this is being kept on a server that's accessible to multiple people. A data breach can happen. I need to give this data to my colleagues in Serbia or in Greece to run some analysis. Someone could access that data. I don't have full control of what's going on, in a different country when I send them the data. That's a potential risk and so on. So that's something that you need to cover. Let's be real. Does this always happen? Sadly not. Usually, at the very least, yes, there are cases even today where people will just be like, assume that the patient is fine. There are with it, which again, more and more patients are getting very sensitive about and checking. So you can't do that. You can't just tell them like, oh, it's fine, or assume that they will be fine with it, right? The other problem is, people who follow this in letter only and will give like a documentation, be like, hey, can you check this box and sign it under? And the patient doesn't know what's going on. He's stressed, he's nervous. He will be like, yes, yes, sign it without you reading it. So that those aren't, that's not informed consent. And sadly, it's very hard to check for informed consent because usually, unless you are an ethical committee that has access to not anonymized data, and that where you can call a patient and be like, hey, did you provide informed consent for this and so on, right? But by the time the data comes to the research is published, the editor can't request and check like, hey, can we give me the phone number of a few patients so I can call them? That doesn't work like that. So yeah, so essentially what we want is we want to make sure that any participation in any research is voluntary. It doesn't have any coercion. It's that people are pushed and forced to do to research. If you I don't want to go into details and stuff, but essentially if you're looking at this and be like, who cares about voluntary participation? I advise you to check the last people who did research on people without voluntary participation, who they were. So beyond that, ethical issues. What are some other ethical issues in personal data collection? Especially when you're talking about these potential risks and benefits. First, risks of profiling people and discrimination based on collected data. As a result of something, people might be. We want to make sure people aren't going to get discriminated. This is something that people want to worry about, and people want to make sure that, hey, this data that I'm giving you, is that going to be something that's going to lead to, for example, someone's care being turned down because I gave that data, you developed an algorithm, and now you're turning down healthcare for someone. That's something that people may have a big problem with. Another example is informed consent for complex algorithms, because technically people should know exactly what's happening to their data. In a complex algorithm, determining how a neural network, a deep neural network with hundreds of connections is working, well, that's going to be a problem. You can't really explain because you don't understand. It's a black box model. So hopefully, what's the goal? What's the point here where you just give up and tell the patient it is what it is? The subject, hey, it's going to be used in a neural network. When you give up because you can't actually explain to them, you can't actually quantify the influence of that single data point they have on the entire element. Because if you're doing something like average, you can show how that one data point influences everything, and why you want. But something with like a very complex algorithm, it might be very, very hard. Again, for studies or applications such as targeted ads, when does targeted ad become a problem? For example, me personally, I don't have a problem with my data being used for targeted ads because I would rather, if I have to see an ad, I would rather see an ad for something that I'm interested in than see an ad that is completely unapplicable to me. It has no sense. It's not something that I'm interested in. But that's me personally. Some people don't want their data being collected, so it could serve them ads, right, that target them specifically. This is especially people say, point out this problem of children, where data is being given to them. Specifically, this is a problem with social media where you create echo chambers because people are pushing, the data that is being served to you, like the posts that are being shown to you, are more in line with what you like. So you are building an echo chamber where everyone agrees with everyone, without you understanding that there are other elements outside. There was a great example in Croatia, for example, with recent elections, with the website the Reddit. The Reddit, Croatian Reddit is very left-leaning, and when you looked at it, because that creates a positive reinforcement loop, because most people are left-leaning, so left-leaning posts get recommended to them more often, and the ads get related to left-leaning politicians get recommended to them more often. The polls in there were showing like 80% victory for the left-leaning political political parties, when in reality the right-leaning political parties won handily. Why? Because this was, basically the personalization pushed towards the creation of an echo chamber, right? So that's something that a lot of people are protesting against in terms of this personalization, as well as losing their privacy. And finally, sensitive data that you share can be used for unintended purposes, used for something that you don't want. If it's identifiable, it might be used for blackmail and stuff like that. So, does anyone here, would anyone here be comfortable sharing their full search history? You know, most people probably wouldn't. But your search history is being collected, especially if you're using Google Chrome. I think by default it collects your search history for analysis. If someone coordinates that to you, posts it online, would you be comfortable with it? That's a question that needs to be asked. So, as I mentioned, I used healthcare data a lot because it's honestly one of the biggest issues, one of the biggest points of contention. Because of course medical record health histories are something that's very private, and that most people wouldn't be comfortable sharing around, especially when it deals with more vulnerable populations, elderly, children, people with disabilities, and so on. Obviously, you want to use the data to improve research, to improve patient care, to improve models that help people. But the reality is there's a careful balancing here to be like, hey, does the end justify the means? If my end goal is to create a good model, is that fine? Is it fine for me to get data without consent? And usually the answer, most people agree that the answer is no. You can get data without consent just because your end goal is noble, because it's impossible to identify whether someone's end goal is noble or not, because anyone can claim that they're doing a research, but once they access the data, they can sell it uh, outside to an outside company, and no one will be any wiser. And these people, with certain disabilities or certain diseases, might get higher insurance rates and stuff like that, because of the data that was shared originally with the purpose uh, for scientific research. So that's something that uh, those are two sides, of and balances somewhere in between, where obviously you want to share some data to do research, because how are you going to do research without any data? It's impossible, especially today, where big data and machine learning requires that information, and it's so good that basically it would be stupid not to use it. and it offers solutions to a lot of problems that were considered unsolvable before. So you can improve patient care, a lot of it. But then again, some people are like, no, we want to make sure patient data is completely private. Again, it's a balancing act that sits there, and that's why we do it. Instead of going one way or the other way, we'll let individual decide. Instead of being like, no, research is king, and we are willing to sacrifice privacy to better research, and we're willing to risk people getting higher premiums because someone was immoral and sold that information. On the other side, you have no, patient information is sacred. It can be shared. Instead of us trying to find the balance there, we just decide, hey, let each individual decide whether they are fine or not with their information being shared, right? And who they are sharing it with and why, and do they trust that person or not? So that's why, patient trust is important. Why is patient trust important? Because if they believe that just by going to a doctor, they are going to get increased insurance premiums because they went to a doctor once and maybe it was something that wasn't serious. Maybe they got a cut on their hand or something, right? But they are worried, oh my God, my insurance premium is going to increase or something. You need to have that patient trust. So people can actually use the medical system and go into the medical system without being worrying that they are sacrificing something by just walking through the doors to their doctor. So what are some other regulations that we need to talk about is data transfers. How are we going to, if Croatia and Serbia have different data regulations. I know that for sure because we worked with Serbian hospitals. How are we going to make sure that we comply over there and they comply over here? Well, we usually go with whatever's more restrictive. If your rule says that you can send it. However, my rule says that no, you can send it by internet. Then we won't be sending it by internet. We're going to follow the more, the harder rule, and create some like a special set of rules for data sharing that between two countries. Usually, GDPR aims to transfer this and define it. So because some people are going to go like, well, data rules are more lax in Croatia than they're in Germany, so we're just going to follow their rules because it's their data. Who cares? This is the GDPR tries to, in part, answer, by having contracts defining stuff. I've sent a ton of these contracts where it defines exactly what we said before. How the data is used, how the data is stored, how the data is shared, for how long the data is shared, and so on. And another thing that happens is encryption. If we are transferring data from point A to B, we are using end-to-end encryption, right? We are not just randomly sending the data openly so it can get intercepted by anyone. And again, often when you sign a contract, like I mentioned here, you will open yourself up to do an audit, essentially a regular audit for compliance, where a person can come in from some organization that's in charge of doing this, knock your door and be like, hey, can I please check your hardware, your information to see how your data is stored? Are you storing it properly? Are you storing it somewhere where it shouldn't be? So what are some other, data storage practices that you would probably need to pay attention to or discuss? First is the usage of encryption for the data in rest and in transit. I mentioned this in data storage and management class, but essentially, if you are transmitting data, don't use stuff that's server and encrypted, because you have stuff that you have your computer uploading it to server, it gets encrypted and then it gets sent over the internet to local server somewhere, decrypted and sent to the person. That's server to server encryption. You don't want that. That's not encryption. That's nonsense. What you want, because if someone is trying to hijack your information, they're going to be hijacking it next to you, right? Next to your computer on your local network. That's much more likely than some hijacking your information on the internet randomly. So you want to have end-to-end encryption where data gets encrypted as soon as you send it, right? You write a message, hit enter, it gets encrypted, and then it gets sent. And it gets decrypted at the other end of the communication channel where the other person when the other person receives it, right? Not so all the information that leaves your computer is encrypted. You want to have role-based access controls. We talked about that, where a student, an administrator, a lecturer have accesses to different student information. That's something that you want to do. Obviously, a doctor and a tech in a hospital will have different access to different information. You don't want to do that. Again, redundant backups. We talked about that at length. And as I mentioned, and I mentioned it again, regularly test and update your storage systems for security, for vulnerabilities. This is why someone, at the hospital level, you should have someone in charge of this, of computer security, not just for stuff like leaks, but lockdowns. There was an example in Croatia where one of our largest hospitals got put under ransomware and a lot of information was lost. So that's something that someone who was in charge there should have predicted as a possibility and dealt with it through backups, through this, through that, through updated virus controls, to why was some person somewhere able to execute a code that locked everything down? Why didn't they have a role-based access control that didn't allow them to lock down anything that doesn't belong to them? Yeah, so those are the questions. You need to have someone in charge to go occasionally, once a month, once a week, once a year, whatever, just with some regularity, go over what's going on in your network and check that everything is fine, that everything is followed according to some rules that you originally set, and that those rules are updated because there's new information happening in the world. So there are something to, we have something that's discussed. Basically, we have privacy by design and privacy by default. This means that when we are designing the systems, you design them with this in mind. You design them with privacy in mind, and that at their default, the data is private. So by default, the data doesn't store information. So if you have a system for collecting patient data, the simplest example of this is you're creating an Excel table where you type in patient data, don't have a row for their name or their identifying a number, patient number or something like that. Right, just that's privacy by design, that's privacy by default, because it doesn't have, and it simply doesn't have an entry where you can type in, the patient's name. And by default, you are disabling people from accidentally making a mistake, typing in the names on autopilot or something like that. Again, as I said, you regularly need to review to make sure that this is fine. The people have a tendency to try and simplify their tasks, shorten them, and this sometimes means, it's simple for me to copy all the patient data, including possibly private data, instead of copying one by one point. And so I'm copy pasting everything inside the table. And yes, there isn't a specific column for name, but who cares? I'm just going to write it, next to this. Next to the other columns is going to be, the name is going to be in there, and then that gets shared, and that's a problem. So make sure that you are checking what's going on. You need to have that proactive compliance. You need to make sure that you shut down the possible issues that can arise with this, because you don't want to assume like, oh yeah, that data is private, share it without checking that someone, 200 rows under has started writing in patient names. So that's something that you need to pay attention to. So in the class Social Aspects of AI, we talked about this at a bit more length, but essentially, what are some possible issues with AI, machine learning, and so on when we're talking about the data collection? You want to avoid biases in data because bias in data reflects in bias the AI. If you have 100, if you have 100 data points, for example, in a patient care, you have all the people are older, all the people who have a positive diagnosis are older, and all the people who have a negative diagnosis are younger. The algorithm might learn that a young person, the age of the person is a key indicator here. And then someone who is younger, who comes in, tries to get, tries to get tested using your model, is going to, by default, the model is going to decide, oh, this person is young, this person isn't sick. Right. That's an example of a possible bias that was introduced to the algorithm through data. So you need to check the data when you're designing, when you're analyzing, when you're checking that, as we talked in the last class here, distributions, statistical descriptors, you want to make sure those are, those are valid, those are fine. You want to have human oversight for critical decisions. You don't want to get decisions that are potentially dangerous. They can be influenced by AI, they can be advised by AI, but the final decision has to be done by a human. And again, when AI is used, let people know that's the fair thing to do, which is like, hey, not just AI, any expert support system is like, hey, I'm using a computer to help me decide. Most people just think that's cool. Most people, like from my experience, most people will be like, oh wow, you have a program that tells you can I see, as opposed to being like, oh my god, AI, no, I don't want that. So just a little bit. But do communicate it. Do say, tell people, hey, part of my decision is based on this computer program that analyze this and let you know. So that's part of the information why I'm basing part of the information that I'm basing my decision on. Again, I mentioned that you want to have a data protection officer and conduct regular audits. This is annoying. No companies want this. No companies want to pay someone to annoy their other people and slow stuff down. But generally, the goal is to have someone, like technical protection in the same way that whenever you start working somewhere, you at least in Croatia, no, in other places, you need, to pass a test that shows that you know how to act, in case there's a fire or if something drops on you, and if you're, working in a more physical work like an electrician, there are stuff relating to that. No one wants to do that. No one wants to listen to that. But you have to, it's those protections are necessary. Same goes for privacy. If you're dealing with people's data, you need to have some things set up in order to make sure that there aren't any significant issues with data sharing and stuff. If you don't care about anything else, you should care about getting fined a lot because you didn't follow GDPR or something like that. It's not all sunshine and rainbows. Sometimes errors happen. Data leaks. What is a data breach? It's any time you release the data that shouldn't be released, whether it's data, anonymized data, or data that shouldn't be shared. So, a simple data breach is you have a table with patient names. You delete the patient names, save it in a different table, and then attach the wrong table. It doesn't have to be malicious. It can be a user error, right? And it's not meant to cause panic necessarily. In some cases, yes. If someone breaks into the system and starts selling patient information on the dark web, yes, maybe some degree of panic is necessary. But if you generally have someone mistakenly sent unanonymized data, right? Data including names or personal identifiers to someone, it's not the end of the world. Have a well-known system that exists in how you're going to deal with that, right? How you're going to take care, depending on the type of incident, what needs to happen, who needs to be notified, whether it's regulatory bodies, whether it's people, how are you going to notify them, how are you going to reach out to them, how are you going to mitigate risks, again, if you're a doctor, you send me and you're just like, oh my God, they screwed up. What is the risk there? Nothing. We shared it with someone who is a researcher who dealt with this before. He isn't motivated to share that information. So it's not a high risk, but you still need to notify people. And again, the same way as, the safety rules are written in blood, the same manner, when you get a data breach, learn what caused it and improve security by writing rules or creating procedures that that aren't blocking, that aren't going to just get ignored by people, but remind them, hey, this person shared this information. We had a lot of problem, so we need to notify people, and so on and so forth. Please don't do that again because it happened already. Please make sure that you check, or let's from now on when you're anonymizing data, don't save it in a separate file, overwrite the existing file so you don't accidentally send data with names outside this organization, right? Stuff like that is what's going to help you. Errors happen. It's not a panic. Don't let your first reaction be fire someone. Don't let your first reaction be like, oh my God, what are we going to do? Just do what's right, what's correct, notify people, write down what happened, write down what you did to mitigate it, make that information public to people who want it, and then move on, create a note, make sure that doesn't happen again, and just move on. It's not the end of the world. As I said, massive companies have had massive data breaches and they survived them, so don't worry about that. Okay, so what about data storage? We don't want to over retain the data. We don't want the data to be kept unnecessarily long. Of course, we don't want to delete the data immediately in some cases. For example, if you're developing, let's say we're doing a research. If the research we're doing is going to get published, either in the form of a scientific paper or a patent or a product, that data might be key to validating the results, right? And someone might request to check the data in the future under proper regulations to make sure that the data is fine, right? And that you don't have the fruit of the poison tree situation where you developed a system based on something that doesn't work, that was invalid, and so on. So determining the time for data deletion policies is a problem, but you even need the time because if you don't have the time, the data is going to get over retained. What happens then? You're creating a bigger risk of data being leaked, right? Because, for example, my computer here, 5 years from now, I'll go work at a different university, is going to stay here. I forgot to delete something. Person who comes in here is going to look at my computer, be, oh, that's old, throw it out. Someone is going to find it. They take out the hard drive, go to see if there's anything interesting, and they find a data set with potentially patient names or something that I have forgotten to delete, right? That's a possible problem. And that's something that, so over-retaining data creates additional risks. And we don't want that. Again, we don't want centralized storage. So we want, if something's highly sensitive, we want to, for example, have data separated, right? We can separate it horizontally. So that means we can separate the data where first 100 patients in the data set are completely on one server, another 100 are on a separate server, then the from 200 to 300 on a third server, and so on. Or we can do vertical splitting, where we will have something like on one server we will have the patient measurements with a unique key, right? Right, and then we will have so for example we have the patient name, like for example Sandy Baresi Shigota, and then number 00555. And then on the other server, we're going to have a file called 0555.jpg, which is going to contain the data, on my, I don't know, my chest X-ray or something like that. So that's something that's, it's split, avoid, it's not centralized. So if someone breaks into the server containing images, or someone gains access to the server, downloads it, they don't know that's my chest X-ray. It just has 00555. If someone breaks into the other server where my name is, they have my name and a number 00555. That doesn't mean anything to them. So that's the idea of vertical separation of datasets. And finally, we want to, again, balance accessibility. You don't want your doctor to have to do 15 tasks to verify they are a doctor. Has the right to access that when there is a patient sitting next to them. You don't want your doctors having to call tech support every 2 days to verify the data, that they can access a certain data because they need to run diagnosis and slow down the entire process. That's something you want to avoid. So yeah, the balancing is necessary. Make sure that people who need the data can access it relatively easily. Okay, so another problem, but basically another additional information is children's data protection. For example, US has COPPA, which has stricter regulations for collecting data from minors. Again, one of the examples is like we are uploading these videos to YouTube. Whenever I upload videos to YouTube, I need to check that there are no minors appearing in them, because again, videos with minors, with children have just in general data has higher protections. Usually, if you want to do research involving child data, you will need the consent required from the child's parent or guardian, right? Generally, one thing that's key that most people agree with is you want to avoid any targeted advertising or something using children's data, right? Because why? Children are more impressionable. It's easier to get children to start a negative habit when they are young, when they don't fully understand the consequences, and get them, essentially cause them issues later on. For example, smoking. It's much easier to get a 14-year-old than a 34-year-old to start smoking. And one is going to spend more money on cigarettes because they're going to be smoking for much longer. So that's, for example, why for a long time smoking depictions were forbidden in cartoons, etc. Since 30 or 40 years. And of course, educational data, healthcare data involving minors requires special care, as I mentioned. As I said, there's a balancing act. Everything in privacy is a balancing act. We don't want to, completely shut down any data-driven research, because shutting down data-driven research today essentially means shutting down complete scientific research in healthcare or in any other privacy anywhere, any other place where you may have concerns with privacy, right? You want to have, because a lot of research these days is data-driven, using machine learning, using big data techniques, using natural language processing to actually figure out things. So that's, again, how do we accomplish this? How do we say it's fine? We want to use anonymized or pseudonymized data. So anonymized data, what is the difference if you hear the two terms? Anonymized data is data where your name has been removed. Pseudonymized data is data where your name has been removed, but it was replaced with something else. Like, for example, your patient identification number. I used 00555 as an example before. Obviously, pseudonymized data is much less secure because if someone figures out what my patient identification number in that particular study is, that is practically, data that's completely that's might as well have my name attached next to it. But why is that necessary? Well, sometimes you want to contact people for follow-up, right? Sometimes you're doing tests over a multitude of years. Maybe you're checking how a treatment for something like arthritis influences a person, right? Does it lower the pain? And it probably won't happen, 5 minutes after you give them a pill. It might be like, you want to check for the next couple of years, each month, whether this person is fine. So in that case, you can have fully anonymized data because you want to know which person is which, right? You want to have a pseudonymized data where that person is going to be referred to with some sort of a pseudonym. What is that pseudonym? Who knows? It could be, a number or a nickname or something like that. Yeah, as long as it's uniquely identifying that person. Again, as I said, regularly engage. You want a new project in a lot of places, right? Any new project, any new research needs to be approved by the ethical board, right? You can just start working on the research. You need to write an ethical proposal, and it will go to the ethical research board, ethical review board, and they're going to determine whether it's fine, whether it's not, whether you need to make certain changes to make sure that this it satisfies the solution, as it satisfies whatever the rules are at the government level or at institutional level. Some institutions might be stricter, right? And again, patients, stakeholders in the hospital, they need to have information communicated to them, especially, the key here is focus on the research benefits. Now I'm talking about actual benefits, like, hey, this allows us, this is an automated system that's going to allow us to check 1,000 people in an hour, right? That means that we are going to practically disappear with the waiting lines, right? And only people who are at risk are going to get invited for checking. So next time you come here, right now you waited for 2 hours for me to see you. Once this project is done, there won't be a wait line, right? And you'll get your results much faster and much more secure because this system we're developing is going to get checked versus doctors, and it's probably going to be more precise, which is true. Today, a lot of AI systems are better than doctors, right? That's what research shows. So if you explain that to people, they're going to be like, oh, okay. A lot of them are going to be much more open to actually accepting that and moving forward with giving the data and participating in the research. So what are some emerging trends? Let's call it that. What are some newly focused things here? First is transparency and explainability in models. All right. As I mentioned, some machine learning techniques are black box. They are so complex, right? For example, a neural network, can you write out as an equation? Yes. If you're talking about a neural network that's 5 layers deep with hundreds of neurons in each layer, that equation probably will take more than a few thousand pieces of paper to write. So it's very, very complex, and you can't tell exactly what's making the decision on. There are techniques such as decision trees where you can go and be like, oh yes, and this is how this influences the solution and so on. So, for example, decision tree. Let me just find an example. It's something like this, and you have based on this value, you have a yes, you have a no, you go to this side, you go to this side, you go to this side, and you can see based on what the decision was, all right, you can explain exactly how a decision happened. You have that well, if we satisfy this was a yes, then this was a no, this was a yes, you can understand how the decision was made. In something like an artificial neural network, something like this, it's much harder to figure out how this input influences this output, right? How is it connected? How are the values? What's going on here? Like, it's complex, and this is a very small neural network. This is a extremely small neural network compared to some that I've seen used. So going with more explainable models, right, is a focus. Of course, obviously, this model here is much more powerful than that decision tree, and that's the problem. And development is being focused on developing these explainable models. So when a patient asks you, "Hey, how did you make this decision? How did my data influence this decision?" You can show it to them, be like, "Hey, here is how." More and more, there's significant growth in the focus on ethical practices. For example, I can tell you that publishing work, publishing, research papers. Today, you have to verify that you have the research board. Every paper needs to include a section where you describe how the data was collected, was it ethical, which review board gave you the approval, and so on. This wasn't the case always, but today, in every paper worth the salt that's indexed in proper scientific databases, this is something that exists as a as a section that is included inside. Again, regulations such as the GDPR get introduced and updated more and more often. How are we going to deal with some modern challenges that are upcoming? For example, wearable rings for data collection. How are we going to treat the data from that? How are we going to account it? And of course, greater accountability happens for third-party data processors. What is third-party data processors? It's if I want basically you have a doctor, you have a patient, and you send me the data to analyze that. I am the third-party data processor. In the past, what was sometimes done was like, oh, the doctor followed all the rules. It sent the data to the third-party data processor, and said like, oh, and then I made a mess. I published it somewhere. I didn't save it, and the doctor wasn't. It wasn't a problem for him because I'm a third-party data processor. I didn't sign any regulatory boards or review boards. He did, so it's not a problem. Today, data processors, third-party data processors will be included in review boards. In that process, you will have to write who are you sending the data to. You won't just be able to be like, oh, the data will be analyzed by someone. This person is analyzed, and I have all the responsibilities as that the doctor sharing the data would have, or any other person, right? It doesn't have to be a doctor. I'm using medicine as an example here. Again, issues exist with cross-cultural perspectives. Not every culture cares about private data so much. Especially when you're working globally, you'd be shocked by how some certain people from certain areas don't care about data privacy at all. In my experience, especially from South America, I got data that was not completely had personal information. When I complained, people were like, "What are you talking about? It's not a problem." This was some years ago, so it's possible the situation has updated since. Hopefully, it has. But yeah, not everyone sees data ethics in stuff that I talked about here as important. Again, some people are leaning much towards the side of who cares, this research will save lives. Let's go to that side of who cares about privacy, right? In those cases, when you're working, the general guideline is, align global operations with the strictest standards. So if I'm working with you in Greece, for example, if Greece has stricter standards than me, we're going to follow Greece's standards. If Greece has stricter standards in one area, Serbia has stricter standards in the second area, and Croatia has in third area. So, for example, Greece is very strict about data storage. Serbia is very strict about how data can be transferred, and Croatia is very strict about how long data can be kept. We are going to use the rules in each of those areas, following the strictest protocol that we have, the strictest standard that we have, to assure it's valid everywhere. So we want to do that. Old trick that was done in the past, where like, oh, Croatia is pretty lax with standards, so we're just going to use Croatian rules because we're working with them, and it's either it's their data if you're receiving data, or oh, we're sending the data there, so who cares? They are processing it, so they will use their rules if you're sending data over there. A lot of examples like that existed where people were essentially making excuses. Uh, Again, cultural sensitivities when you're collecting from different populations. Some populations may be more sensitive or less sensitive to having the data shared, corrected, make it less or make it more, take that into account, make sure, and again, address ethical dilemmas with people from local stakeholders. Stakeholders are people who have, influence here, whether they're patients, whether they are doctors, whether they are local politicians, ask them what dilemmas they have, because I can talk about the dilemmas here for 6 weeks, hold the whole class, and then I'll go home for the weekend to visit my family, and I will ask my mom, "What do you think about it?" And she will come up with an ethical concern I haven't even thought about, because there's a difference in generations and everything. We think differently, right? So that's an example. Talk to actual people when you're trying to determine ethical dilemmas. And don't act like you're the smartest. Don't be like, oh, ethical dilemmas. Here are the stuff that concerns me. Write it down, and don't not include uh, anything about ethical dilemmas that people actually have, because when you're discussing that and trying to figure out the systems for data sharing and data publishing and whatever data use, you won't be addressing actual ethical concerns that people have, and you will lower the trust significantly. People won't want to give you data now or in the future. You'll essentially burn that bridge, and that's a problem for research. So again, whenever we are collecting data, try to prioritize those ethical considerations. Make sure that whatever methodology you're doing follows the ethical considerations of the people whose data you are collecting. Make sure that you follow the regulations in the industry, in the region, European Union or your country or your organization might have its own. Make sure you're up to date to this, you're figuring out what is happening. Money needs to be invested, whether it's, systems for secure and redundant storage, data transfer, right? And people who are actually going to do it, usually people are going to be the most expensive. Even at least in Croatia, a good engineer, an okay engineer, not even like an extremely good one, is going to set you back like for security. We're talking is going to set you back like 36 to 40,000 euros a year, but that's the money you need to invest if you want to actually have money going, have be able to make sure that the data is safe and that you aren't leaking data, you don't have data breaches, and you aren't having issues caused by this. Mostly people not trusting you, because if you're a hospital, you get one data breach, okay, then you get another, then you get another. Are people going to come to you for their primary care? No, they're going to try to avoid you, and that may negatively reflect on their health, because they will be like, oh, I don't want to go to the hospital in the city that I live in, I want to go to a different hospital, and it will create wait times and so on, right? Because they're worried, rightfully, that your data is going to get leaked or something like that. If you're a private entity, you're a company that does AI, machine learning, or something like that. If you aren't following ethical, if you aren't following secure stuff, don't justify that by being like, who cares? I don't care. I only care about money. The reality is, if people figure out, people won't volunteer their data to you. People are going to report you to GDPR. You're going to get fined. You're going to get disallowed for participating into elements. Don't do that. Get someone. Make sure that you are following all the best practices and that you're fostering a culture. That's very important. And that's, in my opinion, one of the biggest problems where where on the paper, people are going to be doing everything right. You have a hospital, you have a large hospital, and you have hired a really good engineer to make sure that your systems are as safe as they can be. No system is ever safe. You have hired someone who has experience in being, data coordination officer, and we follow that, and you are like, oh, I'm fine. I have secure storage, and I have this, and I have that, and I have a ethical review board filled with experienced people. So I'm in a great position, and then your administrators don't care about the data privacy at all, just emailing the data around without anything, right? It's a problem, right? And usually don't figure out problems until they grow. So the person who is your data security officer probably want to notice that I don't know, maybe someone is using their private email to send us the data because they don't like Microsoft Outlook, and that data is getting posted, publicly onto Google Drive somewhere. Yeah, that kind of issues can exist because you didn't foster, a culture in your workplace that has a respect for privacy, where everyone understands, hey, this is a problem. You wouldn't want this to happen to you or to someone else, right? Okay, so that's it for today. We are done a bit shorter. It was a bit of a shorter topic compared to, but so what I want to discuss now is just, so next time we have one more class left. We want to we have basically this topic that is a discussion of examples provided by students or a professor, right? This means that I would like very much if for the next week, let me see, I think it's I don't know when the next lecture is, but I believe it's Wednesday or something like that. You came up with some examples on data collection that maybe you are interesting to you, maybe from your area, because I know that we have a lot of people from different areas here, and just basically be open to sharing them a bit on microphone. Maybe you had a situation when you were collecting some data that you want to share about. Maybe you uh, need to collect some data in the future, and you want to basically uh, to tell us about it, and maybe get some advice on it or something, and so on. So basically, if anything like that interests you, please think about it until the next time. And then I'm simply going to have an open forum. Don't worry if you don't have anything. So it's the class is Wednesday, 18th of December, uh, at 1 p.m. So if you don't come up with anything, I will have some examples of my own to share with you. So to fill out the class, to basically share some information. But if you have anything you want to share, please go ahead, and get that ready for the next time. Okay, that is everything. Any questions? Okay, I see there are no questions, so I'm going to end the meeting. Thank you and have a nice weekend as well. And see you in this class on next Wednesday. Goodbye.